Hello everyone. Today we're going to be solving this math problem. If you would like to solve this on your own, please pause the video right now. Okay, I'm moving on to the solution. So this problem is actually not that difficult, and we can use one essential trig formula, which is that sine square plus cosine square x equals to 1. So now what we're going to do is we have the minus 2 cosine square x on the right side, and we need to move it to the left side. Therefore, we get 3 sine square x plus 2 cosine square x plus cosine of x minus 1 equals to 0. And now, if we simplify this simply becomes sine square x plus 2 plus cosine of x minus 1 equals to 0. And this is because 2 sine square x plus 2 cosine square of x is 2 from this above identity. And now 2 minus 1 is simply 1, so we have 1 plus sine square x plus cosine x equals to 0. Now here is, I guess, the hardest part of the problem, is that we have this equation in terms of sine and cosine, and it would be really nice if we wrote this just in terms of sine or just in terms of cosine, because we can simply solve a quadratic or like any type of polynomial expression by just letting y equal to cosine or sine of x. However, looking at this above theorem, we can simply rewrite this as sine square of x equals to 1 minus cosine square of x. Aha! You see, now we can write sine square of x in terms of 1 minus cosine square of x. Therefore, writing this entire equation in terms of cosine of x. Therefore, we can replace sine square x with 1 minus cosine square of x, and this becomes 1 plus 1 minus cosine square x plus cosine x equals to 0. We get 2 minus cosine square x plus cos x equals to 0. Let's just let y equal cosine of x for simplicity's sake. Cosine of x. Therefore, we get 2 minus y squared plus y equal to 0. And then if we multiply this entire equation by -1, we have y squared minus y minus 2 equal to 0. Nice. Now we just need to factor this. And just from some little bit of trial and error, we can find that this is equivalent to y plus 1 y minus 2, which equals to 0. So now we made a substitution of y equals to cosine x. So therefore we have either cosine of x plus 1 equals to 0 or cosine x minus 2 equals to 0, which means that cosine of x equals to -1 or cosine of x equals to 2. Now, we know that the range of cosine of x is between -1 and 1, so clearly this case does not work. But we know that cosine of x can equal to -1, and that is simply when x is equal to pi. Because on the unit circle, if I want to draw it, when we rotate pi, the x coordinate is basically just -1. So therefore, the answer to this original equation is simply x equals to pi. Now, it asks us to find all x such that this is the case. And since we know that trig functions are cyclic, meaning or a periodic function means like they repeat over and over again, that means that any x, and this has a period of 2, works. Basically, if I have pi and I add 2 pi, this still works because it basically is the same place on the unit circle. So therefore, x equals to pi plus 2 pi n, where n is in any sort of integer, and there's our solution to this problem.